Hey, what's up, everybody? Welcome back to another 3D Hangouts. It's just me today. I'm Noah Ruiz, designer here at Adafruit. Joining me every week is usually my brother Pedro. He is a little under the weather, so hopefully he can rest up and recover and be here next week. But the show must go on, so I'm going to do the show. We got some prototyping projects. We got a Time-lapse Tuesday. Maybe we'll take a look at some CAD stuff. And of course, we're hanging out in the Adafruit Discord server. Let me bring that in. If you'd like to join us, the invite code for that is up here in the purple bar, discord.gg/Adafruit. And you can join us in the community 24/7. Yep. So we're going to take a moment to let folks come in, and then we'll check back in on Discord and say what's up to everybody. This is episode 467. It is Wednesday, January 15th, 2025. I'm going to take a moment to walk through our usual stuff in the morning. We got some deals going on at Adafruit. If you want to support the show and everybody at the Adafruit team, get some stuff. For folks that have an order of $99 or more, you're going to get a free PCB coaster with a golden Adafruit logo. And for orders that are $149 or more, you'll get the PCB coaster plus an Adafruit KB2040. If your order is $199 or more, you'll get the KB2040, the PCB coaster, and free UPS ground shipping for continental US only. So check out adafruit.com/free. These items get automatically added to your cart, so there's no need to do anything special. They just get automatically added at checkout. And while you are there, why not use our 10% off discount code? Works on just about everything in the Adafruit shop, except for subscriptions. Snapcase is this week's coupon code. Let me post that up in all the different channels. By the way, we are streaming on all the usual channels. So hello. If you have any questions, I can pull them in to the show. Questions or comments? There we go. Okay, so support your maker habit and support us by using the coupon code. We really appreciate folks ordering stuff and keeping us going. All right, checking in on Discord. We have a couple folks tuning in live. Say hello to Duester and Paul Cutler. Hello, thank you for joining us live. And we got first question, different camera. No, I just have the normal camera that's attached to my iMac, and I have the portrait mode turned on, so it kind of blurs the background a bit. It's just software stuff that does the bokeh kind of background effect. Anywho, let's go ahead and jump in on what's on my desk. What do I have prototyping? So last week I talked about a project that we were starting up. It's going to be a collab project, of course, with Liz Clark. She'll be doing the Circuit Python code. And we wanted to create a turntable using an IKEA Lazy Susan. So we talked about using the A4988 stepper driver. We gave that a try. We wired it up, and it makes a little bit of noise. So we swapped it out for the TMC2209, which is a trinamic stepper driver that is very, very quiet. So here's the prototype that we have together. I went ahead and 3D printed a tabletop for it as well. Why not 3D print the tabletop as well? Because this is a 15-inch solid piece of wood from IKEA, and I have taken it apart. It's got a really nice mechanism to do a Lazy Susan mechanism, where it just has 3 mounting holes. It's drilled directly into the wood. Here you can see the product info. It's called a Sudon, I think. Excuse my pronunciation, but it's basically a solid piece of wood, and then you have a base, and they just kind of have a built-in ball bearings in between the metal Lazy Susan mechanism. So I have it here. Let me kind of zoom in a little bit on it, and I have these cases here that we'll talk about in a second, but we're in prototyping mode. So what we have is a couple of 3D printed parts. The main thing powering it is a KB2040 right here. And then we have a DC jack to provide 12-volt power. On the inside, you can't really see it, but there is the Trinamic driver, the stepper driver, and then a buck converter that takes in the 12 volts and can downgrade it to 3 volts that the KB2040 needs, but still provide power, 12-volt power to the pancake size stepper motor. So I got some 3D printed gears. I have another piece that kind of covers this, but I have it exposed here so they can make sure I can test things. But yeah, basically the tabletop is secured to the Lazy Susan mechanism that I ripped out of the IKEA Lazy Susan. And one of the interesting things about this print is that I'm not sure if you can, yeah, you can see it there where the light is. I did a concentric spiral pattern on the bottom, on the first layer of this this print. And it gives you this kind of shiny thing, especially with this glitter black PLA from Hatchbox. It looks really cool. And it gives you kind of a point of reference of where the center is. I don't know, kind of a neat little thing about the 3D print part. But yeah, this is what we got going on. I'm really digging this low profile stepper motor. Although we don't carry these stepper motors, maybe I would suggest it. The idea here is to control it with a Stemma QT rotary encoder. So I got this nice knob on a rotary encoder with the Stemma QT cable that makes it easy to connect. And then an OLED display. This is the 1.3 inch OLED. It's just a black and white OLED. And the idea is that you'll have an on-screen UI where you can select direction and speed and maybe the steps. We're still kind of working out. We're collaborating with Liz on the CircuitPython code. But yeah, it's got this little enclosure for it that kind of sticks out. And then it's open on the inside here so I can get the wires from the StemmaQT cable into the KB2040. So let me go ahead and power it on. I don't think I had it wired up last week, but I do have a video maybe I can share next week of just how loud it is, the A4988. But again, this is the TMC 2205. I'm just going to step over here and plug in the power here. And thanks to that bus converter, like I can just power it with this one connection, and it'll power the KB2040 and the stepper driver all nice and easy like. So right now we just have some demo code. We have a little printout here that says the turntable is on, excuse me, and then it'll tell you when it rotates the other direction, but you can't really hear it and it's on, which is great. And there's the 3D printed gear that just press fits onto the shaft of the stepper motor. And there it is spinning. So the idea is, again, that we'll be able to change the direction and the speed of the stepper using the rotary encoder. It gives you the ability to turn left and turn right, to select a menu item, and then you have the click here, which is nice for selecting items. So I was able to turn a 6-pound weight, so I know that it can push a lot of torque, which is really nice. So the stepper motor is rated for 12 volts. I think you go up to 5 amps or so. And the power supply I'm using is just an adjustable power supply. So I just have it set to 12 volts. And you can, on the stepper driver, you can adjust the current limit up to 2 amps, which I just have it on default right now, and it seems to be pretty good. And I'm like kind of pulling force on it, and I'm not able to stop it, which is nice. So that's the gist of the turntable. We're going to work on the code tomorrow and the day after, and hopefully we can get this project released by Wednesday of next week. So there is the screen just saying turntable's on. Careful not to drop these. But yeah, that's what we got cooking right now. I really like that this is so silent. And you can, of course, buy a motorized turntable commercially from like Amazon, but I think it's cool to kind of try out the our new stepper drivers that Lamar's been working on, and she's actually working on a custom library using UART commands, which would be really nice to do some special stuff. But I've looked around for turntables on Amazon. I haven't seen one with like this interesting interface where it has a screen on it. Maybe it's a little overkill, but we want to make a really nice one, and it's not too expensive because the stepper motors what, like $10 or so. Not a bad deal. Speaking of which, this is the stepper motor that I'm using. Let me remove that. Go over here. There we go. It's a NEMA 17 sized, but it's got like this really low profile, which is nice. Same mounting holes as a normal NEMA 17 big version. It's from a brand called Stepper Online, and again, it's rated for 12 volts DC. And there's some nice data there. It comes with a nice diagram and a spec sheet that lets you know what the wire connections are. So it's really easy to connect this up to the terminal blocks on the Adafruit TMC 2209 stepper driver. And they have a whole bunch of different ones. But I'm digging this low profile one because it makes the base of this project nice and relatively slim. You can see here, I have some extra room in here just because I want things to kind of not smash into each other. So I got a little bit of height there, but I think it works well. I can, of course, swap this out for the original thing, which I do have in today's video. So it's just using the same mounting holes because the Lazy Susan has these like mounting holes, and they just, I just unscrew it and screw it into the wood with these wood screws. But I just have this here because it actually fits better on my desk. And it's all 3D printed, and I kind of want to talk about that cool effect that you get. That's an interesting spiral radial effect when you select that in your slicer. So that's the gist of the project. I think I covered everything. Let me check in on Discord and see if folks have any questions about it. Go over here. Tyeth is asking if I have tried a larger stepper originally. No, I have played with a regular stepper motor. If we go to the Adafruit shop, we can search for stepper. And this is the one I've used before on like the Circuit Python camera slider project. I just wanted to try this this shorter version of it. Let's see, what is the differences between the heights? I think it's basically half the height. Let me see if there's a data sheet with height differentiation. Yeah, so it's about 34 millimeters thick, and this one is about 20 millimeters thin. So you shave off about 14 millimeters, which is, I think, substantial. But yeah, they're pretty much the same. 12 volts rated. Yeah. And you can swap them in and out, which is nice with the screw block terminal on the TMC 2209, which is the stepper driver. So if you want to pick these up, they actually are in stock. They are really nice. I really like how silent it is. You can't really hear it. And of course, you can get 10% off if you want using our coupon code SNAPCASE. It's a nice little segue there. But yeah, that's the driver. And the other thing I'm using for the power is the MPM. Yeah, I'm using this thing here. This was a recommendation from Lamar. It can take in up to 21 volts, and then it can do 5 volts out. So it kind of steps it down so that I can power the KB2040 dev board, and then also power the stepper driver and the stepper motor with 12 volts, not through this thing, but like sharing off the DC line and the jack back there. Yeah. Yep. Tyeth is saying the pancake shorter version is neat, presumably less current too. Maybe useful sometimes, although the normal one in the store is really low current. Yeah, I see that. Yep. Good stuff. Okay. So hopefully next week we'll have a nice interface and we can adjust the speed and the direction, which I think is the main things that we want to do with the turntable. And if folks don't know what a turntable is normally used for, it's for video production, photography. That's pretty much what they're used for. I've always wanted one. Pedro actually has one that he got off of Amazon, but it's pretty simple. You just turn it on and it goes on. You plug it into the wall. pretty similar. To what I got going on, but it's nice to have the speed control and motor control. And I think with the UART command, we might even do ramping to do some cool like speed up and slow down kind of effects, would be nice. So yeah, this week we wanted to do a video on our 3D printed cases that are produced by JLC PCB using their 3D printing services. We are stocking these in the store. We have about, well, I've lost count, like 6+ versions, different cases. They come in 2 different versions. Most of them do, or at least one of them do. We're still experimenting with which ones we want to carry. But we have this clear resin and this milky white resin that's available. They all have Adafruit. Most of them have Adafruit logos on the back of them. They snap fit. No screws are required. So we just wanted to come out with a video to kind of promote that these are available in the shop. And we are working on more. I actually have some on order. And folks can always just let us know what enclosure we should design next, right? I try to make it so that these have, because they're printed in resin, they're really high quality. So we can do some fine details like some onboard text or some built-in text. So here you can see that it says DC in, USB here, and then over here we have some text that says like bat and load. And then on some of the other ones here, of course, we got the Adafruit logo on the bottom. They have these mounting tabs that are useful. They're M3 sized mounting tabs. So folks can attach these to a surface, like maybe you have a piece of wood or something you want to attach it to. This one has screw block terminals, so we have exposed ports for those, and the top here, so you can still screw it. This one says ground, and then this is, I believe, 3 volts and 5 volts. Let me see if I can. I'd have to change the lens here, but you can make out the text, and it's printed in this white material, so you can see the LED shine through, which is nice. Here you just have a plus and a minus, which is nice, nice and big there, and then USB there, and the JST to PH jack there. So we have a few of them. We also have the Trinket ones. It didn't make sense to create mounting tabs for the Trinkeys because these are ideally going to plug into a port. Most of the boards that have like onboard buttons, they try to create these like press tabs, so you can still select them with the covers on. Most of them are 2 pieces, with the exception of the Cutie Pie version. And then this is just an empty one here. Yeah, I think we only have 2 versions of the clear resin, they're really cool, but they're a little bit more pricey. So yeah, just keep that in mind. They're pricier because they have a spray varnish that makes them really nice and glossy, but you can see through it, which is really cool. And they're basically the same, like temperature resistance and stability. So you can kind of make out the logo there, but pretty cool. And I have a turntable so I can kind of show them off all fancy like. So these are in the Adafruit shop. If you go to the /new, you can see this is the latest one that we have in stock. It's the Adafruit USB solar charger with the 3.3 volt buck. And did I mention? Yeah, no screws needed. You just kind of line it up, push it in, and snap the case on there. I always do my best of testing them out before we get them in the shop. I order them on JLC PCB and test it out, make sure all the tolerances are right, all the ports line up, and then I approve it, and Lamar will take a look, and she orders them up. So this is pretty cool. Yeah, I want to make some more. Right now I have the Feather RP2040 DVI Feather on order, and then I think I want to do the Feather 2350 after that. Yeah, so that's what I'm working on in conjunction with this project here. So yeah, check out these. This one's out of stock because folks bought it up. So thanks for buying it up. Hope it works out. Let me know what you folks think about it. Yeah, we're digging this. So we're gonna keep making some more. And if you want to pick up any of the cases, of course, that are in stock, be sure to use our 10% off coupon code SNAPCASE. And we appreciate your orders. And I got some comments. From YouTube, let me pull those in right now. We got one from Azaz, built to goat. Cool, just bought these. They are 20.5 millimeters thick, which is pretty thin for NEMA 17. Yeah, I'm digging this. I'm thinking I might want to use the stepper motor for our camera slider that we're going to work on this year. Yeah, cool. All right. So that is what I'm prototyping. That was this week's video, these cases, working on more. Pedro is working on a kind of timer visualizer for toddlers, which is a project that Lamar and Pedro are working on. They're kind of ideating, and he's kind of coming up with the enclosure design for it. It's going to have, maybe I can show you folks here in the photo. It's there in the background. Yeah, it's going to have some light in NeoPixel strip and gives an idea of how to visualize time with NeoPixel LEDs, which is kind of cool. Okay, how is Discord doing? Good. We got some gifts from Yanni's school. Got a nice turntable with the turtle on it. Very cool. Yeah, I think when I first suggested this project, I called it a motorized turntable, and Lamar probably thought it was a real turntable. She was asking audio questions. It's like, is it going to be fast enough? And I was like, this is for photos. Yeah, confusing. I know. Okay, let's see. Next up, I think I'm going to talk about. Let's take a look at some CAD. So I'll share what I'm working on in the turntable, just because we have some time, right? So why not show that off? So hopefully I can bring this in. Okay, so here is the design in Fusion 360. Let's see. Let's get rid of the top here. So this is what it looks like without the top cover on. You have this this mounting plate that attaches to the Lazy Susan mechanism. Let me see if I can isolate the Lazy Susan mechanism. So I started off this design with like designing this mechanism. This is what it looks like, more or less. It's got two pieces, three mounting tabs that are about 5 millimeters in diameter, and there's like a center hole there. But these are two pieces with a little bit of gap in between them. And I did apply a little bit of lubricant to kind of smooth it out because it was a little dry. So I might recommend that in the Learn guide. But yeah, it's a pretty small, low profile Lazy Susan mechanism. And then I went ahead and modeled the base. It came with this pretty thick, solid piece of wood, and just a bolt in the center with a nut. But this is the model. It's 15 inches in diameter, which is fairly large, and it's how thick is it? It is 16 millimeters thick, which I'm not sure what that is in inches. But I basically started off with modeling this first, and then modeling the things around it. So let me hide that for a second, and then take a look at the rest of the stuff. So the gears I'm using a plugin in Fusion 360 that's called GF Gear Generator. I've been using this for all my geared projects. It just provides you, it's a kind of like a Python script that allows you to select your module size, which is like the size of the teeth, the number of teeth, the height of the gear, your pressure angle, and your radial thickness if it is an internal spur gear, which this is. So it's an internal spur gear. And then the gear for the stepper motor is just a regular spur gear. And for this particular one, I went ahead with a 2 millimeter size. And I forget what the teeth are. Here it is, 16 teeth for the stepper motor and 86 teeth for the tabletop base that attaches to the Lazy Susan. So that's how I was able to create those. I used some joints to position the motor, and then I'm using motion linking with some revolving joints to kind of figure out how far of a distance these gears should be to each other. And then the motor mount itself is this green thing here. There it is. I have it selected there. It has 4 mounting holes with a center hole for the shaft of the motor to pass through. And then it has these kind of thick mounting tabs that have these drafted edges so that I can 3D print this upside down like that. And they have M3 size holes so that I can secure it to the bottom plate. But pretty simple. There's no supports needed again for it. And I think it's like 3 millimeters thick. So it's hopefully plenty thick. Seems to be nice and rigid. And what's some other pieces here? Let's take a look at the electronics here, how they're mounted. I figured I have this this panel mount DC jack. It has its own kind of mounting tab. And then the KB2040, it doesn't really have any mounting holes. So I came up with this special snap fit mounting plate or bracket, I guess we can call it, with some chamfered edges here that allow you to kind of flex the PCB so that it or flex not the PCB, the mount, so you can get the these little nubbins underneath the PCB itself. So let me see if I can get a better look at this. Yeah, so you can see here how it just about clears and covers it so it doesn't move out of place there. But then it has these mounting tabs on the sides, so I can attach that to the bottom plate with these built-in standoffs that are part of the bottom plate, and they're just M3 size. So kind of a neat idea. And then the bottom of the plate here, of the mount rather, has enough clearance for the mounting holes, or not the mounting holes, the pin holes, I guess. The castellated pads to kind of have a little bit of room here in case you have a little bit extra solder or, you know, pins that kind of show through. So that's working. And then let me hide this, you know, hide the gear, and then this plate here. And then I have another PCB mount for the TMC 2209. You can see here it's pretty much the same mounting holes as the 49, the A4988 stepper driver. I didn't add it in here because I haven't created a 3D model of it yet, and it has the same mounting holes. So maybe I'll update that later. And then here's the 5-volt converter for taking in the 12 volts and downgrading it to 3 volts. So they're all separate mounts in case something changes. I could always change this out instead of having it built into the bottom plate, because then I'd have to print the bottom plate all over again. So that's one of the things I like to do, is to keep all my things modular. So you can see here the bottom plate is like just has a ton of these mounting holes for all the various PCB mounts. The only other enclosure bit is the OLED rotary panel, which is pretty simple. It's got an interesting kind of drafted edge for the faceplate, and it's got this nice rounded cutout, and it's open on the back here because it allows the table to kind of pass through it. So there's the OLED, and then the rotary encoder there that just gets panel mounted, and there's some M25 screws that will secure the OLED to the 3D printed enclosure. And then there's 2 mounting holes here that attach to the bottom plate. To keep the bottom plate, or rather to keep the Lazy Susan supported, I had to come up with this part here, which I'm calling the Susan plate. I should probably come up with a better name. But it basically just allows you to attach the Lazy Susan using that bolt and nut that came with the IKEA Lazy Susan. So the nut goes in here and the bolt goes right through there. I haven't modeled the bolt, but that's basically what it does. So this attaches to the bottom base, and then the Lazy Susan is attached to that plate there. So there you can get a good look at how it's kind of working. And then once you add the 3D printed tabletop mount, and then add the teeth, And then the stepper motor. Where's that stepper motor? There it is. And then the stepper motor gear. Then you can get an idea of how it's working there. Where's the stepper motor gear? Right there. And there you go. That's how it's all working together. A lot of times I'll use a section analysis, which lets me see a cross-section view. Let me see if I get a better view of it. Maybe this way. Yeah, this way I can kind of see how all the clearances are working out. Yeah, so that's pretty much the design. Oh, and the last bit is this frame here that kind of covers it up. It gets attached to the bottom plate and has these built-in standoffs. Where are you, Case? There, you can see the mounting tabs here. There's just 4 mounting tabs. And then it has these openings here with a flat surface for the DC jack and the USB-C port of the KB2040. So there you go. I think that's going to do it for the CAD stuff. There we go. Of course, 3-printed knob is its own thing. Yeah, so I'll share this file, of course, next week when I release the Learn Guide for it. But yeah, it was a fun one to come up with. Continue to make more spinning projects with motors. So that's fun. All right. If there's any questions or comments about the CAD stuff, I can pull them in now. I have to reshare my web browser. Just a second here. Cool. We got a cool link of a project, the motor cell, from Yanni from microbots.io. Take a look at that after the show. The platform for the lasers would be called the table. Yes, good idea from Hesitant Road. Yeah, I'll be sure to come up with a better name. Let me check in on my turntable. How's it doing? It's still spinning. Very nice. Yeah, very nice. It was suggested that the zipper drive can get a little hot, so I'm probably going to add one of these little heat sinks to it just to cool it down, and I might add some ventilation to the 3D printed bottom and the the kind of framing that's supposed to cover. Whoa! I just dropped everything. Awesome. I'll probably add some ventilation holes on the side here so that if the motor gets hot, it'll have a little bit of ventilation. But so far, so good. Fingers crossed it doesn't overheat or anything. And I do have some clearance here, so in case it does get a little hot, it'll cool down. Oh, it's out of focus. Come on. Yeah. Luckily, I have carpet, so nothing broke. Good test of the parts. Okay. Next up, we have a Time-lapse Tuesday video that Pedro puts together this week. It's this air pressure rocket. It's designed by PatoPato Designs. Wish I could talk more about it, but it's like a fun, example of using kind of a 3D printed kind of spring and a button and kind of launching little 3D printed rockets by pushing down on that button. Yeah, seems pretty interesting that it can that you can make something like this with all 3D printed parts. Maybe next week Pedro can talk to us about it. It is on Maker World. That's where he found it. Again, from PatoPato Designs. I believe it is a free model that you can download. And here is the nice GIF. What is that? It says over 300 centimeters. Maybe that's how high it can launch. Punch and fly. Can fly up to 300 centimeters. Cool. Yeah, I guess it has a tight tolerance. so that when you push down on the button, it can push air through the little channel here and then send the rocket flying. Kind of a cool physics kind of example. It's really, really interesting. I haven't printed it myself, but Pedro did, and I think the kids enjoy it because I saw him post my nephew playing with it. It seems pretty cool. So yeah, just a couple parts, and you got yourself a fun little physics toy that's all 3D printed. Pretty cool. All right, next up, we are going to jump into community makes. These are some posts that were shared with me. Starting off with this make of the Raspberry Pi Zero Game Boy build. This was posted up by Baka Sanke, and they are working on the builds of the Pi Girl, is what we named it. It's the Raspberry Pi Zero Game Boy build. They said, cool print. I'm still waiting on some of the components, so I haven't built it yet, but it looks super high quality, and it press fits really well. Very nice. Good stuff. After that, we have a make from JS94 of our Halo Energy Sword prop. They just made the handle to go with my collection of lightsaber hits, probably hilts, that also have no blade. And yeah, it looks like it's been sanded and spray painted or painted. Yeah, this is a cool design that Pedro came up with a couple years ago. And I think he redid it with the RP2040 prop maker not too long ago. Very cool. And then after that, we have another make of the prop maker lightsaber. It looks like these are just the mounts for the PCB, so they're probably still working on it. No comment, but it was posted up by a photo rammer. Cool. And to end it off, this week's community makes, Aero Steve O posted up their make of the new Pixel LED gas mask. And this looks really fantastic. I think I came up with this project a while ago, like 2014 maybe. It uses the NeoPixel ring in the filter area, and then it has some EL wire, I believe, on the goggles, because Adafruit stocks these goggles, and I thought it'd be cool to kind of make a semi steampunk sci-fi inspired Vader mask inspired prop with these lights and the EL wire, when EL wire was like the thing to use in props. Nowadays we have LED noodles, which would be a lot brighter. So maybe I'll revisit this one day. But yeah, it was cool. It's when I was first getting into props and stuff, which is pretty cool. So it's printed on Ultimaker 2, Matter Hackers filament, and some notes. Printed and picked up the parts back in 2017. Finally assembled and completed it using WLED and an ESP32 to drive the LEDs and a relay unit to turn on and off the EL wire. That is cool. Wow, that's nice. You get the parts X amount of years ago, finally put it together. It's so cool. Yeah, it's a pretty fun build. I like the look of it. I think I wore it once for Halloween. Cool, and that is all the community makes this week. All right, I think I'm ready to end the show then. Just a short one since Pedro is out. Hopefully he'll be back next week. We can talk about some of his projects that he's working on, maybe a new time lapse as well. But yeah, that's going to do it for me. Don't forget, before I close the show out, if you want to support your maker habit or, of course, the Adafruit team, you can use our 10% off coupon code at checkout. Snap Case gets you 10% off. Pick up some motors, some cases, some LEDs, whatever's in stock. I got one last thing. I got another question here from Arun. Are the plans to make the CAD files available for the Feather RP2040 USB host? The older Feather cases and Lurgan seem to have a design for micro USB that doesn't have the button tabs. Ah, yes, I remember that. It was the Feather box. Yeah, I think at some point I need to need to create like a new Learn Guide or dedicated GitHub repository with all of our SLA cases that we're stocking, because there's really nowhere to host them yet. So yeah, I'll have to work on that. But yeah, those aren't easily available yet. I don't think I have the Feather host available. Let me take a look here in the Learn Guide real quick. And then I think it makes sense to start posting links in the product page so it's easy access. Actually, yeah, this one is out. Cool. There's I guess I did do a case for this one that was originally just a PLA 3D print, and then only later did we start stocking these for SLA. Yeah, so let me post that up. That works. Yep, no problem. And I'll go ahead and post that one up for Arun, so you can check that out. Yep, most of these are available. Some of them I don't think, like these solar cases, I don't have them up yet, but I always try to kind of release bigger cases, like for feathers, especially because they're dev boards and they get used a lot. But yeah, we'll work on that. That's a good suggestion. Cool. All right. Give folks a couple seconds, minutes here. Let's see. We got one from Tyeth. Do they qualify for the CAD parts repo? Do they have a product ID? That is true. Yeah, they do have product IDs, so you should be able to just add them to the GitHub repo. CAD parts. Yeah, that's a good idea. All right, that makes it easier because it's already a repo. Yeah, good idea. That's what I'm gonna do. I think after the show, I'll start adding these cases with their PIDs. That is that. Thank you, Tyet. That really helps out. I didn't even think of that. Yes. Toe beans. All right. I think that's going to do it for the show. Thank you, everybody, for tuning in tonight. I want to invite you to the show and tell every Wednesday at 7:30 p.m. Eastern Time. You can come in and join the community, show off your projects, your progress, your arts, your crafts, all that's fair game on Adafruit's Show and Tell. You'll want to join the Adafruit Discord. And then a few minutes before the show starts, PT or whoever is hosting will post a StreamYard link where you can just hop on. And then around 8 p.m. Eastern Time, Ask an Engineer starts with open source hardware news, new products, top secret stuff, and more. Every Wednesday at 8 p.m., Ask an Engineer. And you can ask your engineering questions at the end of the show, or as we're starting to do, gathering questions. John Park is back. He'll be doing his workshop, I think, Thursday, if all is planned well. And then on Friday, it's either going to be it's a deep dive on Fridays, 5 p.m. Eastern or 2 p.m. Pacific, with either Tim Foamy Guy or Scott Shawcroft. Deep dives on Friday. And then I need to come up with I need to get the new banner for this. Lady Ada's streamings on Sundays are still happening. So get subscribe on YouTube or wherever else to get notified when she goes live. Okay. JP's product pick of the week is on Tuesdays at 4 p.m. Eastern. Yeah, where you can get up to 50% off select items. This week was the SCD CO2 monitor, I believe, which was like half off, which is crazy because it's an expensive sensor. So that was nice. And yeah, every Tuesday. Cool. Thank you, everybody, for tuning in on this solo edition. Hopefully, Pedro will come back next week, where he'll be refreshed and recovered. Thanks, everybody, so much for watching. I will see everybody next week. But until then, remember to make a great day. Bye, folks.